My name is Milton Smith. I'm one of the leads on the for the security program here on Java. So while we're waiting for everybody to come in here, has anybody been to Las Vegas? Yeah. Yeah. Has anybody seen Blue Man Group in Las Vegas? Yeah. Okay. Has anybody seen what happens when you walk in late? I hear a few laughs. Yeah, anyway, my wife and I were going to Blue Man, and she was really stepping it out because we were late. And so anyway, we got there on time, sat down, and it was kind of funny. This couple, husband and wife, and a couple of kids sat down, and all the lights in the theater turned onto this couple that was being seated, and the blue men that were up on the stage jumped down from the stage and ran over and tried to get them seated. And meanwhile, everybody in the audience was focused on where the house lights were, and that was directly on this family being seated. I don't think they'll ever be late for something in Las Vegas again. But we're not going to do that to you at JavaOne. So I've kind of taken some photos here and used for my presentation. Right here is my sister-in-law's cat, Kitty Mao, in a defensive position behind the couch. I just thought it looked cool since I'm a security guy. Okay, so I've got some information here on my background, really included for when this thing is recorded, but I know my information is in flyers and stuff, so I'm not going to really cover that, except to say that I'm a leader for the security program on Java. So we're going to cover a bunch of different things, talk a little bit about the security track and how we do things on the security track, and then segue into a little bit about security remediation and what we're doing on the platform. And then we're going to start covering a little bit of a history on security changes that we've made and improvements in the Java platform. Some of those starting in Java 7, which you might not be aware of, and then leading up into features that we've delivered for Java 8. Then, after that, we will look into, we'll kind of cover some of the session highlights that you'll see in the security track throughout the week. So I think this is kind of an interesting session in that, so first let me just start off to say that anybody who is presenting here at JavaOne is very high quality session, but we're going to cover the best of the best here. And then we'll provide some closing thoughts. So this shot here I thought was kind of cool because the angle that I captured here, you see the no swimming sign, and in fact you see people swimming. So I think there's something humorous there, and it really depends all on your perspective. If I took this shot from a slightly different angle and you just saw people swimming in the water, it might not be very interesting. And I think that's kind of like security. There's different perspectives, and everybody has a little bit different perspective. And the more that you know or understand about security, the better your perspective is. And so why did we decide to include a security track at JavaOne? We've had security content as part of JavaOne for a long time, but there's a very strong interest in security. Interest in terms of course, what we're doing here at Oracle, but also people that attend JavaOne want to know what they can do to be secure, and what are the new security technologies, and how do they use them. So improving understanding of the different APIs and resources that are available, as well as the threat landscape. What are the bad guys hitting on? Defensive measures for those, and then new platform security features like I mentioned before. The other thing is that prior to the security track, content was very, scattered across different tracks. A lot of content was considered part of core technologies, which it still is today, like security APIs. But the security track gives us a nice place to corral this content. This right here is the second track that we've had. I was asked to lead it the first time and asked to lead the second, which is great. One of the things here as the leader is that you get to choose the committee that will be helping you to review papers in the presentations that are here. Another thing about the security track is it's very defensive in nature. So there's a lot of offensive conferences like we'll say Black Hat or DEF CON where they tear things up and break things, whereas here, most everybody in the room is really interested in how we build our systems and how we defend our information. We've got a lot of different interests captured here. We've got government, financial sector, technology, hardware device makers. So this right here is the little bit of transparency for the track. I'll just kind of share who the different members of the committee were that helped to make the decisions about what to bring to you for this week. So we had Frank Kim from SANS Institute, David from Carnegie Mellon, who's sitting in the audience over there. Thanks for showing up. Robert Secord, another one of the CMU leaders. Sean Mullen from our vulnerabilities team, very sharp guy. Eric Koslow, one of my fellow comrades in security, and myself, of course. So now so we've talked a little bit about the track, and what we'll do now is just kind of segue into remediation and what we've been improving in the Java platform. We don't really, for obvious reasons, share any vulnerabilities that would place anybody at risk that uses Java. But to add a little bit of transparency, what we do show is what we've done in the past, perhaps show a little bit about our tempo, and also where we've made some improvements. So before we show that information, one of the things that I'd like to share is a little bit about Oracle nomenclature. So you might think that a CPU is a little chip that's inside your computer that's the brains of the system, but at Oracle, CPU is a critical patch update. It's our security fix. And the idea of the CPU is that it's our goal to only deliver the security patching, and that way we keep the operational risks at a minimum. We have had to kind of take some liberties there to get fixes out quickly, but that's our goal. Security alerts are more the hot sort of fix for security. So if there's a breaking vulnerability that we need to address fast, we can't wait until the regularly scheduled CPU. Then we create a security alert or a hot fix to address that concern immediately, and we've done that. And then the other thing I'd say is that, so I show some release swags in here, because some people are more familiar with seeing things in terms of dates, others perhaps in terms of release. So I've included some markers here for you to look at. The engineers have asked me to say that this does not include CVSS 0 vulnerabilities, which are more the, ones that you have to combine with other vulnerabilities to actually perform an attack. So as you can see from the left-hand side, in 7U5, we were fixing about 14 vulnerabilities per CPU, and then play that forward to around February-ish of 2013, we were fixing about 55 vulnerabilities in the platform. And then it dipped down and back up, and of course, it's come down since then. But this kind of gives you a good idea of the numbers that were addressed in the platform. So this right here is a little bit different. This shows the remediated vulnerabilities by component subtype. And one thing I'd like to say about this information that you're looking at here, this is all publicly available information. So if you go out to Oracle's, you do a search on Oracle CPU, you'll see a lot of different information about Oracle security fixes for different products. Java's out there. And you can take this information, just like I've done, and pop it into an Excel spreadsheet and kind of, form some interesting picture of not so much what's out there now, but what has been done. So starting off on the left-hand side, you can see we have some high numbers here in deployment. And in fact, that is one of the areas where we've had, over the last 2 years, a lot of concern. Deployment would be like Java applets and WebStart. And so I think the press kind of captures Java vulnerabilities and just kind of throws the word Java out there. But in fact, most of them have been focused on deployment. And then, of course, 2D and JavaFX. But then going, more towards the right, you can see that these, a lot of these packages that have been here for a long time, the number of vulnerabilities drops off precipitously. And then, this machine here, does anybody know what this is? This is not an alpha typewriter. Enigma, perfect. So this right here is a German encryption machine used during World War II. I was at the RSA conference earlier in the year, and the fellow from NSA History Museum brought that in, so I thought it was kind of cool. Okay, so what we'll chat about here real briefly is we're going to kind of speed through some of these different Java 7 features. And the reason we're talking about these features is because I'm not sure that everybody knows what's been rolled into Java 8, and then we'll talk more about Java 8 features. Okay, so starting off here in about 7U10 timeframe, we added support to, there was some concern about being able to disable applets, when there's a vulnerability and Oracle hasn't got a fix out fast enough. Hey, we just want to turn it off. How do we do that? One of the things that we noticed is one of the great benefits about Java and being multi-platform, it was very hard to talk somebody through how to shut it off on each different platform. So we just added a simple on-off switch to turn it off in 7U10. Hardcoded best before date is really about, since we have regularly scheduled CPU or security patches that are published a year in advance, we know that the time for a patch has elapsed, if you haven't applied the new one, we know that you're probably operating unsafely, being that you're unpatched. So there's some changes that we can make here to the behavior of the Java platform, or not so much in terms of shutting it off, but perhaps maybe communicating certain actions that somebody would do with an elevated level of risk. So the Java security slider was another feature that we added. We wanted to allow sites to have some capability to adjust the security features of Java to be more in conformance with their enterprise policies, and that's what adding the slider was all about: the balance of security risk with maybe ease of use. Then the other thing that we noticed, since security is a journey, or that's the saying that goes, one of the things that we learned is by adding the slider, everybody would just go ahead and throttle it down to low or custom and turn off security. And of course, that's everybody's prerogative to do so, but I guess one of the things as a software developer is that if somebody changes the security or turns it off and then they get pwned, then they call us too. So we have to have a certain balance or minimum. So in this case, we actually took away these options and we added new options, which we'll discuss a little bit later. The other thing that we did is it used to be in Java that signing established permissions for the application, but that's not really industry standard practices. So privilege assignments really need to be separate from identity, and that's what code signing is all about. So what we did was to separate the two, and so we added signing for sandboxed applications. So now we'll say a Java applet can be signed, but whether or not it has privileges to the operating system is a completely separate setting. In addition to code signing and making code signing stronger, we also had to standardize our revocation services and enable them by default. So prior to 7U25, revocation services were turned off, but somebody could turn them on. But it's much more safer to run with a default where they're enabled on millions of laptops and desktops, but people can turn them off if they want. But in order to get to that point, we had some issues with interoperability with different CAs that are partners that have certificates in our trust store. So we had to do some testing with them, which we still have to do today as we maintain that certificate store. But we had to make sure all that was working properly for both CRL and OCSP, which are a couple of popular protocols for revocation. The other thing that we had to do is there was some concerns about repurposing jars for, downloading a jar and repurposing it for other applications. And so to deter that practice, we added some support for jar locking to lock jars to a specific server. Then in 7U40, I think we added one of the most powerful features, and that's the deployment rule set. So one of the things that we noticed is that there were a couple main vectors of exploitation for desktops and laptops, and that was spear phishing attacks, where you get an email, it looks like it's coming from your friend, when in fact it's coming from somebody you don't know and has a little bit of extra functionality that you might not be aware of. And so malware payloads were being delivered as part of spear phishing emails. Also, with the way ads work in browsers, sometimes ads were being delivered by third parties or parties of other parties, and so the advertisements were becoming a vector for malware as well. So we developed a new feature called Deployment Rule Set, which addresses that concern by allowing enterprises to whitelist their corporate assets or the assets of their partners. So using this tool, you could set up, that you'll allow applets to be loaded from company.com, but nobody else. Or maybe company.A.com and company.B.com, which is your partner, and then nobody else. So it really helped a lot. And we have another feature that we delivered later, which I'll make note of, but it's more for the consumer. This right here is an enterprise feature. It's delivered via XML in a jar and pushed down to desktops. The other feature that we added was just when a JRE is out of date to pop up a warning and let people know. And of course, at the time that we created this warning, it generated a lot of concern by enterprises because those users then called their support staff and said, hey, why am I insecure? And I think, so we're kind of rolling through these features pretty quickly, and they all kind of make sense when they're strung together. The thing is, from an engineering perspective, you can't always deliver all the features at the same time that would be the best from a user perspective, right? Sometimes you just have to turn on the stoplight and make it blink before you can actually coordinate them, right? And that's really kind of what was happening here. We had to warn people quickly, and then we eventually, when we had other features available, we allowed enterprises to go ahead and turn this off or customize it. The other thing that we had to do is we added support for improving support for the Java Uninstaller so that we could clean up, do a little bit better job cleaning up after ourselves, because one of the areas that's continually concerned is old versions of Java that are installed. So when we patch Java, we address security concerns in the latest versions of Java, and we hope everybody applies those security fixes, but in fact, many don't. So we have to address security concerns going along that line, but then we also have to look at how do we clean up that old stuff where people aren't maybe paying attention or tracking it as closely as we are. So cleaning up the installer is one area, and then I'll share another area as we get later in the presentation. The other thing that we did is pushing forward in our security journey for applets is we established code signing as a default for Java. So if you want to use applets, you got to have signed code. And that's really what that's all about. And then exception site list is really the consumer. I had mentioned earlier the deployment rule set, which is the enterprise whitelisting feature. Exception site list is more the consumer-based feature. So if you're just a single workstation, or maybe you've got a computer at the house that has Java on it, you'll have a screen, depending on your operating system, that looks more or less like this. This one was taken from OS X, but you can see kind of the exception site list and where it fits in there. But that's for the consumer to protect themselves, or maybe you could whitelist Pogo or something and not accept applets running from elsewhere. So they can do the same thing. Okay, so now we've talked about security features that we've been delivering against for last couple of years, a year and a half or so. Now we're going to talk about some of the JDK 8 security features. So JDK 8, of course, includes all of the 7 features, plus these other ones here. So one of the things that we did for Java 8 is establish TLS 1.2 as the default. And by doing that, of course, it makes security much more stronger. TLS 1.2 is a newer protocol. And this, again, is for transport encryption. So like when your browser does HTTPS to another site, this is kind of what we're talking about. It's the underlying transport security mechanism. The other thing is we added some support for enhanced revocation checking. There's a lot of things that can happen when you're doing a revocation check, when you're connecting to revocation services. It could be that there's some intermittent network connection where the site is always operational, but for some reason, your connection to the revocation server didn't make it. It doesn't necessarily mean that that certificate is bad, but what should we do in that case? Do you, as a developer, want to try another connection and see what happens, or how should we handle that failure? And so this is kind of where some of this revocation checking enhancement comes about. Another feature that we added for Java 8 is a new static analysis tool called JDEPS, and it's really for checking for class dependencies. Say you've got some open source packages that you're including. JDEPS can help ferret out some of those. And the significance of that from a security perspective is that if you're including open source that has not been assessed, maybe you're including a certain version of Log4j, but you only checked an earlier version or did a review on that, and then you find out engineering's included a later version. Well, now you've got you have some code that's now in your product that may not be assessed from a security perspective. So it's kind of an interesting tool from that perspective. Type annotations, once again, not necessarily a security technology, but it does offer some, security bonus in that type annotations can be used to do taint analysis on strings. So Washington University has been experimenting with this and has some annotations to actually check for different sort of string tainting, worth checking out. Another feature that we added was an addition for TLS, and that's the server name indication extension, which is for really helps to bring us more into the cloud world where several servers might be served off of a single IP. And this will communicate that information so that way the server infrastructure understands what the original domain was that was asked for, requested, so that the proper handoff can happen. And then we've got a whole battery of technical improvements that I'm not going to really dig into, but I did mention or place here. And in my, as we get into reviewing the sessions for the week, I'll communicate where that extra technology, where you can find that information, the details. Okay, this is my dog Oreo. Now, I debated about when I put this in here, I thought, maybe they'll think the Java team is lazy or, everybody thinks a little something different. This is true love right here. This dog is napping in the captain's chair. And she only does it when I'm not there. So that means she's probably in that chair right now. Okay. So now we're kind of looking at some of the sessions that we have coming up in the week here. We've got Applying Java Cryptography by Eric Koslow, who's on the Java platform team with me and a security colleague. I'll be going over some of the cryptography features. We've got Simon Bennetts from Mozilla Foundation, who's also part of the OWASP group, which is a group of security practitioners. He's going to be talking about OWASP ZAP, which is really cool. Basically a security proxy tool, but it can be used for any kind of proxying you want to do. It's I guess it's based on what's that package? Peros proxy, loosely based on Peros proxy. They kind of downplayed the percentage of Peros code that came over as part of ZAP. I'm not really sure why they do that because I love Peros as well. But anyway, so Simon's going to be talking about that. I think it'd be a great discussion, something for everybody to listen to, especially if you need to use proxies on the job to change HTTP headers or just examine what's going through. 5 keys for securing Java web apps. Frank Kim is going to take us through that. Frank Kim is an instructor on app security from SANS Institute. SANS is probably one of the most highly respected application security training centers around. A lot of the government agencies go there for their training. So if you are lucky enough to go to SANS, you'll see some squirrely sort of people walking around not talking to anybody that are dressed smartly. Okay, now I want to really highlight this session here. So this is leveraging open source for secure Java web construction. Jim Manico, who is a secure coding instructor, Manico Security. This book here I wanted to highlight because it has some special meaning to me. I helped out on this book as well. It was just released this month and is, I'm told, is in the Oracle bookstore at the event. Wink, wink. If anybody wants to get this book signed, my partner, he's laughing back there. He's like, yeah, keep going. Anyway, we just had a fantastic time doing this book. We really kind of battled out what was to go in there. Everything from just logging and tearing up chapters and rewriting chapters. Anyway, we had a fantastic time doing this book, and for those that buy it, we hope that you enjoy it. And for anybody that does and would like to have the book signed, Jim and August are here, and myself included. That's all I'll say. Continuing on platform and web app security, we've got code-level security games and puzzles. This is one that kind of caught my eye. That looked pretty interesting. I'm always looking for something kind of fun and a little bit edgy for the conference, maybe that we wouldn't quite look at elsewhere. And others on on the review team thought so too. So I think this is one I wanted to highlight. Anatomy of another Java zero-day exploit. This is David will be providing this session from CMU. And last year, David did a very similar presentation, really kind of thoughtfully pulling apart a real exploit to show engineers what does the code for a real exploit look like. And I thought he did a really great job, so I specifically reached out to see if he could help us out again. Q&A with the security group. So I wanted to highlight this. This is the Oracle security group on Java. This is the technical staff that researches vulnerabilities that we receive, as well as works on features. And Frances Ho, who is here now, but she is going to be at this talk, and also as she leads the team. Also Sean Mullen, who's on the committee for the security committee for the conference here that does the white paper review. He's going to be on speaking on there. And also Brad Wetmore, who is soft-spoken, but one of our brightest leaders here. So these three people are going to be speaking there. It's a great opportunity if you have specific questions about the technical aspects of Java security APIs to sit in there and have access to them. Okay, so continuing on, I got to speed it up here. Java Secure Coding Guidelines. This one caught my eye. This is being delivered by Andrew Gross, who is also on Frances's vulnerability team. Andrew's really special because he's the guy that gets the vulnerabilities first on the team. And he does the triage on all the different things that we see, works very closely with researchers. So if he's doing a talk on Java secure coding, then it catches my eye. Java native interfaces. This is Mark Schoenfeld, who is another member of Frances's team. The security vulnerabilities team, and is going to be talking how to secure your apps from JNI. And then inside the Cert secure coding standard for Java, so Oracle and Java has secure coding guidelines for the Java platform. The Cert guys really have picked up from that and kind of transitioned to a very detailed standard on different areas of Java technology. Anyway, they're going to be sharing their coding standards. And I did want to highlight their book too. I don't actually know that that's at the bookstore, but it's available on Amazon. It's still it's not new, but it's still relevant. It is at the bookstore. Okay, thanks. I was going to also cover security, Internet of Things. Everybody's coming from a different perspective. A lot of folks are interested in Internet of Things or IoT. So we have some discussions that are happening, some sessions around IoT and Oracle's efforts. On Wednesday, I'm providing a session basically introductory on security and threats around IoT. And I'm going to also bring in, not that it's super IoT related, but I'm a software guy and I like to get on my hardware mojo. So I built a ADS-B aircraft transponder receiver using Raspberry Pi and software-defined radio and some other stuff and kind of put it together. It's nothing that's like... I'm not saying we're unleashing it here for the first time, because I did see a presentation that was done 3 years ago at DEF CON in the same sort of area. I just think it's cool, and I noticed a lot of other people kind of liked that when I blogged about it, so I'm bringing it in. Hopefully we can detect aircraft inside the Hilton here, but if we can't, we'll just merely walk outside after. Internet of Things security architecture. So both of these next two sessions here are being delivered by Noel Poor, who is the lead architect for security on Oracle's IoT efforts, and really kind of the mastermind putting everything together. So I specifically wanted to kind of call him out. And I think if anybody was interested in the specifics around the protocols that we're using and the real details of device provisioning, all that sort of stuff, those would probably be interesting sessions to attend. All right, here's my dog again. All right. Okay, so one of the things that I wanted to just kind of cover is, as we close out here, is just some common security myths or misnomers. And just to kind of give you something to think about. So a lot of people think that being slow to upgrade or patch is best for production. And I think the reality there is that there are some operational benefits of not being an early adopter, obviously. The other part of that, though, the equation that most people don't consider, is that specifically with Java, because Java is open source, and that we publish the source, when we publish those security fixes, all the bad guys know what we fixed. So it's, it's a roadmap for exploitation, and that's why we encourage everybody to patch as soon as possible. So keeping up to date on Java CPUs and upgrading older versions of Java is a good thing. The other thing would be another misnomer. Hackers need my code to break into a web application. That is patently not true. In fact, your code might actually confuse hackers. I know mine would. So I think the deal here is integrate testing and development process, address vulnerabilities earlier instead of later. Okay, now another point here, another misnomer is attackers or hackers are uniquely gifted individuals. I think media likes to play this up. I think whenever a company gets hacked, they like to play that up. But the reality is hackers are really the same as engineers. Yes, you've got some gifted ones, just like you've got gifted engineers. I mean, we've all seen code that really gifted engineers can push out, and that's the same as hackers. I think that hackers are overly esteemed because it's a way of shifting vulnerability or shifting responsibility. And so I think what we need to do is we need to always be vigilant. And we need to be performing independent assessments of our code, getting outside opinions, and not focusing so much on the attacker, but focusing more on what we can do at whatever level we're at. Another one that I see, another misnomer, is that we've never had a security incident, so we're secure. I think that's another one that's patently false. Just because you have not had a security incident is not the same thing as knowing that you're secure. Okay? So knowing you're secure implies that you've done some sort of work or assessments on what you have to be able to have a basis for that foundation. So the action item here is work to understand your landscape, your threat landscape. You don't necessarily need to fix every vulnerability, but you need to fix the ones that matter. Okay, so moving on, security and compliance are not the same thing. If you don't do compliance, you get fined or you go to jail. Security, you've got some more leeway there. But having good compliance is not the same thing as good security either. So work on establishing strong security programs across many different disciplines: security operations, security compliance, network security, security architecture, throughout the entire life cycle. And again, catching things earlier allows more influence to fix. Stepping in front of the freight train later on as software is being deployed is very challenging to do so. Okay, the last one, security is impossible. This is not true. Saying security is impossible is like a doctor shooting the patient because the patient is sick. You do your best. Whatever it is, do your best. Dedicate whatever you can. And it does make a difference. And so that would be an encouraging word I would like to leave with you. So another thing I'd like to announce here is getting back to what we were saying about uninstallers and cleaning up after old versions of Java. We've also been working with Microsoft to clean up old versions of Java on the Microsoft platforms. And so we've been helping them with a feature that they have called updating outdated ActiveX controls. And we've shared with them how you can check to see what the most recent security patch is of Java. And so based on some of these checks, it changes the behavior of the Microsoft platform and IE to prompt people when Java's out of date. And you can read about more of that in the link that I've included there. And I think the impact there is that we all know how big the Microsoft platform is and how many desktops it touches. So I think even though it's not a direct change we make to the Java platform, anything that we can do to help make people safe, that's what I'm going to do. And I don't think that while we compete on many different levels, I don't think that we want to compete on security. Platform support, I'm not going to spend too much time on that, but I get asked about support all the time. So there's a lot of different support options. If you're still using Java 6, there's still work going on in Java 6, and in fact, we patch it. So you need to be looking into these support programs for your data center. I think it'd be a positive thing. That's what I would do. I included some of the upcoming CPUs. As I said, we do publish CPUs or the security patches a year in advance, so I've included some of them in the slide deck here so you can look at. And then I have a few actions here that you can do based on whether you're an end user or a software developer to help keep your community safe. So keeping your JREs up to date, defense in depth. I mean, use the Java security features that we've talked about for sure, but also consider your platform security features. You know, have you hardened your Windows or OS X operating system? Do you have virus scanners deployed? Do you have firewalls? All these features are helpful. And when you stack them, you make things more difficult for attackers and maybe a little bit more difficult than they want, so they'll move on somewhere else. If you're a developer, you know, take your code and try to certify on the latest versions of Java that we have, so that way it allows those that use your product the ability to update quickly. So by letting them update quickly, making it easier for them, certifying on the latest releases will reduce their level of exposure. And then, of course, signing applications and timestamping. And then applying secure coding guidelines for the Java language. I've included a couple links here. Actually, we've got a plethora of security links, but I wanted to focus on the ones that matter the most, and that is the Java Security Resource Center, which is really our landing page for Java security. So you can go to this page and you can find all sorts of other links depending on what your role is. Are you a security practitioner? Well, then we think you'd be interested in this. Are you a Java developer? Well, you know, you might be interested in these things, APIs. And then I've included the Java Platform PM blog, which is usually written to by Eric in the back there. Thank you. We talk about a lot of time-relevant issues, whether we're talking about applets or new security features that we've come out with and how you can apply them to your enterprise. Those are the kind of timely topics that we talk about on the security blog. And then that's really all I have. So I'm going to go ahead and close out the session. And if anybody has any questions, you can feel free to come up. Thanks.